Okay, for this problem number 3, we have a triangle located at these coordinates along x, y, z axis, and we need to find the following vectors and quantities or parameters. Okay, first we have the RAB, RAC, and then the angle at vertex A with the theta BAC, and then the vector projection of RAB on RAC. Okay, so I think the first two are very simple, RAB and RAC. Okay, we know already that in a triangle, this is a triangle in 3 dimension x, y, z. So RAB is a vector from point A to B. Okay, and then RAC is the vector from, or the ray from A to C. Okay, so very simple. So we have we don't need to draw the triangle because we're just simply looking at the vectors. Okay, so RAB we can simply write directly from A to B. So therefore vector B minus vector A. Okay, so you have negative 2 minus 6, so this is for your AX, then plus 3 minus negative 1. You can also write this way so that you will not forget, no? And then plus AZ, so you have negative 4 minus 2. So this is therefore equal to negative 8 AX, 3 plus 1, so that's 4 AY, and then negative 4 minus 2 is negative 6 AZ. Okay, so that's the vector. If the problem didn't ask for cylindrical or spherical coordinates, so okay. So letter B, so RAC. So from A to C, so therefore C minus A. So you have negative 3 minus 6, and then 1 minus negative, okay, AX plus you have 1 minus negative 1 AY plus Z, so you have 5 minus 2. Okay, I hope you follow. So you have the answer negative 9 AX plus 2 AY, then plus 3 AZ. Okay, so these are the two vectors. Okay, so now the angle theta BAC, assuming this is our triangle. Okay, so in this case we need the drawing, but we know that this is triangle, so we assume that this is a triangle. Okay, so with this is A, B, and C. So assuming this is a triangle. Okay, so we're asking for the angle theta BAC. When you say BAC, that's the angle here. Okay, at vertex A. If that is ABC, so the angle should be in the vertex B. Okay, so in this case, this is the angle that we are concerned. Okay, so the angle theta BAC. Okay, now if you want to get the angle, we need to do the what you so called the dot product. Okay, the dot product is simply the dot, let's say vector, because in this case this is you see this is the RAB, and then this one is RAC. Okay, so these are the vectors. The dot product, okay, is between RAB, okay, and then dot RAC. Okay, now take note, can we use the vector BC or CB? No. Okay, because it's not part of vertex A. Okay, so only the two vectors in the vertex A. Okay, so that's why the problem is asking for RAB and RAC, so that the values there will be used for this problem, no, for the problem C. Okay, so the dot product, the formula is you have the dot product of two vectors is equal to the magnitude of the product of the magnitude of each vector. So you have RAB, then RAC, then multiplied by the cosine of the angle between them. So in this case, this is theta BAC. Okay? So if you are looking at the ABC, so vertex B, so what you're going to use here is RBA and then RBC. Okay, that RBC is equal to the magnitude of RBA and then times RBC cosine theta ABC. Okay, but in this case, we're using in a vertex A. Okay, so now the dot product here, we multiply each of the, it's like the element wise multiplication. So we multiply each element. Okay, so the value -8 for the RAB. So this term in the right left hand side, or in your left, in your left is a element wise multiplication. Okay, so you have element wise multiplication, then the sum of that product. Okay, so you have -8 times -9 plus 4 times, okay, you see -8 for the AX times -9 of the AX of the other vector. Then you have AY 4 times 2 plus -6 times 3, and then equals to the magnitude, we can actually use our calculator directly to get the magnitude. So you have 8 squared plus 4 squared plus -6 squared. So you have 2 square root of 29. Okay, the magnitude is just taking the sum of the square of each of the element and then take the square root. Okay, and then the RAC is, you have square root of 9, -9 squared plus 2 squared plus 3 squared. Okay, so you have square root of 94, and then cosine theta BAC. So therefore, to get theta BAC is very simple. So you got you have cosine theta BAC is equal to the quotient of, okay, so you have -8 times 9, so positive, plus 4 times 2 plus -6 times 3, so that's 62. Okay, and then divided by 2 square root of 29 times square root of 94. Okay, and then if you try to solve this using your calculator, you have 62 divided by 2 square root of 29 times square root of 94. So you have 0.5937. Okay, I'm using 4 decimal places to be more accurate. Then that's cosine theta. So to get theta, you just take the cosine inverse, okay, of 0.5937. So using our calculator, which is the default, is in degree. So the cosine answer of this is 53.58 or 58 degrees. Okay, so that's the, okay, which is correct, or 53.6 degrees is okay. Okay, so so the 2 square root of 29 is the magnitude of RAB. Square root of 94 is the magnitude of RAC. Okay. Now this is problem C. Okay. Now how about problem D? So this will be our last. Sorry. How about problem D? So the vector projection of RAB on RAC. How do you solve it? For problem D, the idea is the vector projection of RAB. So let's say this is your RAB. Okay, this is the vector A to B, point B. So this is RAB. The projection of that vector to vector RAC. Okay, and we know already that the angle is theta. Okay, the physical meaning of this is that you have the magnitude RAB and you wanted it to project to RAC. Okay, so what we can do here is to take the what you so called the magnitude of RAB, taking the magnitude of RAB. Okay, let's say this is the magnitude, and then okay, represented by the red line. Then we project that one in RAC. So to project that one, just take the cosine. Okay, so the projection is this one. Okay, this value here. Okay, how to get that value? You have the magnitude of RAB cosine theta. Okay, and after that, because it is projected in RAC, we need to get the unit vector of RAC. Okay, so that's the unit vector AC. So that value there, that value, let's say, I don't know what, let's say D. That value D should be multiplied by the unit vector from A to C. Okay, so that's unit vector AC. Okay, so to be more precise with the equation, so we express this one. So this is equal to the magnitude of RAB. Okay, okay, you can write RAB, magnitude of RAB, and then multiply a projected to RAC, so that's a cosine theta. Okay, cosine theta. So we know already, no, cosine theta is equal to adjacent, which is D over the hypotenuse, which is RAB, di ba? Okay, so therefore D is equal to RAB times cosine theta, which is this case, no? And then we multiply this one with the unit vector of AC. Okay, the unit vector along AC. So it's not that product. Okay, so let's okay, so this is the answer, the equation. So we can put that one, so just to represent that this is a unit vector. Okay, then you have RAB. The magnitude of RAB is equal to the square root of negative 8 squared plus 4 squared minus plus negative 6 squared. And then cosine, we already have the cosine here. I mean the theta. The theta here is BAC. Okay, so that's why in the previous problem C, we have theta, finding theta there, no, which is BAC. So that's 53.58. Okay, and then the angle AC, sorry, the unit vector AC is simply okay, we solve this one first. We write AC here. Okay, and we solve that one later. So this is the square root of 8 squared, 4 squared plus 6 squared is equal to the 2 square root of 29, and then cosine 53.58 times the unit vector AC. Now, to get unit vector AC, simply the division of the vector RAC divided by its magnitude RAC. Okay, so therefore you have here 2 square root of 29 cosine 53.58, then multiply by the product of RAC, which is negative 9AX plus 2AY plus 3AZ divided by its magnitude, square root of negative 9 squared plus 2 squared plus 3 squared. Okay, then you try to solve that one using your calculator, then you will get negative 5.94 AX, and then plus 1.319 AY plus 1.979 AZ. Okay, which is the correct answer for D. Okay, so that's the vector projection of RAB on RAC. Now, if it's reverse, RAC on RAB, so very simple. You just replace the RAB with RAC, and then the angle theta is the same, 53.58, because it's between the two vectors. No, you just change the two vectors respectively. So and then but also the unit vector should be along AB. Okay, so that's it for problem 3. So we will end in this part.